Right, okay. Good morning, and we are going to discuss 2017 May June paper 9608, the first question. So it's asking about the database concepts, right? Database concepts, and the first one, first question, some shops belongs to Rainbow Retail Buying Group. They buy their goods from one or more suppliers. So this retail shop, so they buy their goods from one or more suppliers. Supplier has, so each shop has a unique shop ID and single retail specialism. So what they are selling, each supplier has unique supplier ID and a similar single specimen or specialism that is also recorded, right? What they're asking. So Rainbow Retail creates a relationship. Rainbow Retail creates a relational database to record their data about shops and their suppliers. So asking the ER diagram, and this is straw foot notation is given. So you can see. So the notation is also given. Shop and supplier tables are shown. So explain what is the degree of relationships. That is means, so in other way you can say cardinality or optionality or participation in the relationship. That means for one shop, how many suppliers are participating? For one supplier, how many shops they can sell? So according to this Crawford notation, this clearly say this is many to many relationship, right? Because one shop can buy from many suppliers, and one supplier can supply to many shops. So it is called many to many relationship. Is it clear?
Yeah.
Right. So what are the other relationship types that you're having other than many to many?
There's a relationship between the shop and the shop supplier.
No, I'm just asking about the other cardinalities, other optionalities, or other so degree of relationship. So these all three words are referring to same, right? Degree of relationship. So sometimes they might ask cardinality, optionality, or degree of relationship. All three are same, right? Referring to the same. Right. That means how many, so per one shop, how many suppliers? One supplier. So other two are, so it can be one to, so one to many is another one, and one to one is another one. So we have three kinds of, it can be one to one. One person has one head. One head, so particular head belongs only to a single person, one to one relationship. Right. So one to many relationship. One to many relationship means one hand, many fingers. Those fingers belongs to only one hand. Right. Likewise, so that one to many, it can be, so these are not very good examples, not related to IT, but anyway, so showing the participation on the degree, it can be one to one, one to many, or many to many. Here it's many to many. Is it good to have many to many relationships in ER diagrams? Is it good to have many to many relationships in ER diagrams? Yes. Many to many තියෙන එක හොඳයිද? Or do we need to change the relationship? Do we need to actually rearrange the relationship? So what do you think?
We could rearrange.
Yeah, we have to rearrange. Why? Right? Why we have to rearrange? The reason for rearranging? Because if you keep many to many relationship, that will result multiple values in a single cell. That means in shop cell, you have to put many values sometimes. One supplier, so related to, let's say, supply XYZ. So supply XYZ is supplying to shop 1, 2, 3, and 4. Then if there's a table, shop and supplier is XYZ, then inside this shop cell, so it's like this, right? So if you think one side, so here if you create a table, so one side you have supplier and the other side you have shop. and think that this supplier X, Y, Z is supplying shop 1, 2, 3, and 4. So this is multiple values. Then it is violation the normalization, or it will violation the normalization. So this is not even in the first normalized form, because in the first normalized form we discussed in the first normalized form. So we have to remove. We have to keep the atomic values. Remove the multiple values. So we have to keep atomic. Otherwise, what will happen? So if you want to remove a supplier, so maybe X, Y, Z, you are going to remove. That may remove other. So that is like a deletion anomaly. That will even remove the shops, right? So if you want to remove a shop, then how to search? If you want to remove a search, because it's multiple values, no unique way to solve. So that is, so you have updation anomalies, deletion anomalies, insertion anomalies also. So this is not in the first normalized form. And the other hand, so let's say there are, so for shop 1, so these are the suppliers, X, Y, Z supplies for shop 1, and PQR is also a supplier. Let's say ABC also a supplier for shop 1. Likewise, again, the other side also multiple values. So you can't keep like that. This is not normalized. It will cause deletion, insertion, updation anomalies, right? If you cannot understand, please tell me, right? Then I can further explain that. Because if you have multiple values, how to update, right? How to delete. So let's say you want to delete ABC supply. Then how to search the ABC supply? ABC supply is only part of this supplier, right? It's not the atomic value. We can't delete like that, right? I think you understood the issue, right? So that is the basic issue of having this many-to-many relationships. And degree of relationship is anyway many-to-many. So you're asked to explain. So if you write many-to-many, that's you'll get marks. The database design is as follows. Sure. So they have rearranged. Right now you can see they have rearranged. They have broken down. They have like splitted this to one-to-many, two one-to-many relationships. What is this two one-to-many relationship? And so shop, and you have shop supply in the middle. Shop ID and sub. This is actually, so you call what? The shop ID is a foreign key from shop. Supply ID is a foreign key from supply table. Foreign keys together. So using foreign keys, you have created another primary key. You call what? Composite or compound primary key. What that primary key? Is it composite primary key or compound primary key?
Composite.
Sure. So what's the difference between composite and compound?
Composite is a group of primary keys.
Composite is also a group of. And both are composite and compound, both are. So not single one. So both are groups.
Yeah.
So then what's the difference? Yes, what's the difference? Composite was compound. So what's the difference? Composite primary key was compound primary. But I'm not going to tell this the Composite means mixture of different components. Compound means it is not the English meaning, right? Should be primary key. Don't take the English meaning. Right here, so you can see this is compound primary key, right? This is compound primary key. Why compound primary key? So you can see compound primary key is created when two or more primary keys from the different table present as the foreign keys within an entity. Compound means you take primary keys of other tables. Here, you take primary key. This one is a primary key. So you take primary key of this table and primary key of this table. Together, you create a primary key. Then that is called compound primary key. Right? Composite primary key means any two attributes together using as a primary key, then it's called composite. So please write down if you don't know, right? So this is compound. Compound means you create using other. Create using other, compound. Composite means you use two or more keys, simply. So anyway, this is also composite. But the specialty is this is compound because we are not using any other. Except we are using two primary keys of some other table as foreign keys. These foreign keys together create the primary key and compound. Okay. So if you want, just take a screenshot of this one. So I'm not going to, because it will again take some more time, no? So this explanation is good. Here. Compound is similar to composite. Right? However, compound key is created when two or more primary keys from the different table present as the foreign keys in the entity. Foreign keys are used together to create the unique identifier. That is the compound. Compound is also a composite. Okay, when there's a composite primary key, there's a second issue. But I'm trying to explain the theory, right? I'm trying to explain the theory also with the question. But I can easily give the answer for the question. But we have to plan for the future questions also now.
Yeah.
Right? Therefore, you should know the underlying theory. Otherwise, we don't know the future question. We can answer this one easily, but the next question we don't know. So if you know the theory, then we know how to answer the next question also. So that is our goal. Okay, then, right. Now you see, so it uses compound primary key. When you introduce compound or composite key, so there might be violation for the 2NF. So normalization. First normalization focusing on atomic values. Need to remove these multiple values or need to remove these repetitive values. Repetitive multiple values. You have to remove that. Then you have secured the first normalization. To secure the second normalizing, you need another property. Can you remember that? You need to assure another one. Especially it is violated, it might be violated. It's not, it is violated. It might be violated when there's a composite or compound key. What is that? There's a special word. First normalization, the special word is atomic values. Many-to-many relationship might violate that. So they have actually taken this to 3 tables to stop this many-to-many relationship. So now it is, so mostly it is in the 1NF. Now we are going to check the 2NF property, second normalization. So if it is like a single key primary key, then it is, if it is in the 1NF, then that is in 2NF also. But if it is a composite key or compound key, so it can be violation for 2NF. What is that? Can you remember the normalization part or not?
Yeah.
Okay, 2NF violate any. Can you remember something called partial dependency?
Yeah.
Right. Why partial dependency happen? Because if any other key, if there's a key, right? So this is my table. Okay, let's go back and this is, let's say this is my table. And in this is my table, this is like C column 1, this is column 2, This is column 3. This is column 4. And this is column 5. Let's assume like this, column 5. And let's say this column 1, column 2 together perform the primary key. This is together create the primary key. And this is composite day. Keys then that is called composite key. But assume this, if this C4 or some other value is only depending on C2. That is called partial dependency. That means a non key value is depending on part of the primary key. That is called partial dependency. Can you remember? Now, hello?
Yes, sir.
Can you remember now?
Yeah.
If a non key is this part of the primary key, story comes when this is a composite key. No, if it is a single key, do we have part of the primary key? If it is only a single key, if this is the key, if this is the only key, do you have part of the primary key?
No.
No, you don't have, because it is single key. But if it is like 2 keys only, you have this part and this part. This part and this part. When you have 2 keys only, you have part of the primary key. So when there's a composite or compound key, there's a risk. The risk is whether any attribute depend on part of the primary. If so, the second 2NF is violated. But fortunately, there are no other keys in this table. You can see there are no other keys other than this primary key. Is there any other keys?
No.
No. So no partial dependencies. So this time again you are lucky, no partial dependencies. So what about the 3NF? Third normalization form. First normalization form, atomic value. Second normalization form, partial dependencies. Third normalization form, 3NF. Yes? It seems that you cannot remember the stuff now, right? 3NF focusing on something called transitive dependencies. Transitive dependencies. Here, the partial dependency we knew. But partial dependency is where partial dependency, a non-key depends on part of the primary key. This happens only when there is a composite or compound primary key. So please write down, right? And so this is for the second normalized form, 2NF. 2NF. 1NF focusing on atomic values. 2NF is actually 2NF is not partial dependency, right? So don't misinterpret the note. I'm telling the key feature of the dependency. If no partial dependencies, then that is if all values are atomic, then is 1NF. If no partial dependencies, no partial dependencies, then that is in 2NF. Okay, the third one is 3NF, third normalization form. And in 3NF, need here actually, so there should be another one. Table should be 1NF, right? 1NF and no partial dependencies. Here 3NF, to secure 3NF, table should be 2NF and no transitive dependencies. So what is transitive dependency? Transitive dependency is where a non-key depend on another non-key. Transitive dependency is non-key depend on non-key. A non-key depend on non-key attribute, which is called, right, a non-key depend on non-key attribute. So which is called transitive dependency. A non-key depends on non-key attribute. That means here this table, let's take this table, same table as the example. So if there's a dependency, like 4 depends on 5, 4 depends on 5, or 5 depends on 4. If there's such thing, if there's such issue, then that is called transitive dependence. Because so anything, any key should depend on the primary key only. So that is the ultimate goal. Any key should depend on the primary key, not part of the primary key, not on other keys. So that is how we divide these two tables, right? Finish writing. Okay, quickly finish it. You can show the examples also. And if there's a table like this, if let's say C3 depend on C2, then partial dependency. If C4, 5 depends on C4, then that is transitive dependency. So if no such dependencies, we can tell that table is in 3NF. So anyway, to table to be in 2NF, it should be there in 1NF also. If table to be in 3NF, it should be 2NF also. Okay. Finish. Right. Okay, let's move to the paper. But then the database design is follows. They have given the database and they have created a shop supply table. Tables shop is previously used. Primary keys are not shown. Label the entities, draw relation ER diagram. So you have to draw the ER diagram by labeling this. And so in the middle, so it should be shop supply, but that's why we have just broken down this shop supplier in the middle. So use capital letters, right? Because that is how they given. So the shop supplier here, it should be, yes, what is here? Shop. Can you hear me? Hello? Siddhas?
Oh, sorry, man. It was muted.
Sorry? Ah, right.
My mic was muted.
Okay. Shop and shop supplier. Then you can use the draw food notation, same draw food notation. And you can just link this to this one. This to this one. And we have just split out this one to many, sorry, many to many relationship. So in draw food notation, you can say this is the many side thing. Shop has many shop suppliers, and supply also has many shop suppliers. මෙහෙම දැම්මම හරි. Cell shape one that is easy to draw the draw food there. Okay, this is how we are going to draw the relationship between these two entities, 3 entities now. Shop, supplier, and supplier because of this many to many relationship. Okay. Right. The next one. Let's go to the next question. Complete the following table. Show each database table. The primary key, foreign keys, if any. Each table may contain none, one or more foreign keys. For table with no foreign keys, write none. And explanation of the use of primary key. Right? Explanation of the use of any foreign key. Right? You have to write that. Okay, so shop table. What is the primary key? Shop table. What's the primary key?
Shop ID.
Shop table, yeah, shop ID. Shop night ID, correct. So any foreign keys? Any foreign keys?
No.
No, none. You have to write shop ID here. So when you write like this, please shop ID. And here it should be none. Explanation, you don't need explanation because you are not using supplier table.
Supply ID is the
Supplier ID. Yeah, that is the one given. And here none, right? So no explanation. Shop supply table.
Shop ID and supply ID.
Yeah, it has both. Shop ID and supply ID both. Because that is how they have created it. Shop ID and supply ID both here. Shop ID, supply ID both. Then what are the foreign keys?
Both.
Both. Shop ID, supply ID both are foreign keys. So what is the explanation? So why both are used?
So it can
because you want to
connect it.
Yeah, you want to. So many to many relations. You want to break down the many to many relationship, but you want to connect both tables together, right? So you have to stop many to many relationship, but you have to still connect both tables. So linking both tables. So if you have explained that, you'll get the full marks. Okay.
Yeah.
Right. Then database design has implemented supplier contact person as a secondary key. Describe the reason for this. Right, they are going to introduce supplier contact person as a secondary key. Database designer has implemented supplier contact person as the secondary key. Asking the explanation for this. Why? Any reason for doing this? Why you need secondary key? Why you need that? So basically, why key values? Key values are for indexing or searching purposes. So that's why key values are used, right? Indexing or searching purposes. Yes, so that's how key is representing. For an example, your ID is representing you. My ID is representing me. If someone asks my ID, so I know that information about me can be found using the ID. Right? ID එක කවුරු හරි දන්නවනම් මගේ. So most of my information can be මගේ information ගොඩක් ඒවා හොයාගන්න පුළුවන්. It's representing me. So basically ID is for indexing, searching, right? Representing me. So if someone is introducing a secondary ID, a supplier.contact person, right? Supplier.contact person means supplier table again. In the supplier table, the contact person is also a key. So why secondary key? Because you need to search, right? You want to search. So basically ID is like, so it's not like ID you need. ID you need to do the operations, database operations, but frequently you are searching from the contact person, right? You can mention that. So keys, right? Keys are introduced for indexing. So let me write keys keys are used for indexing, searching. Keys are used for indexing, searching, and representing the record. Here, practically, we need to search. Practically, we need to search, index, and quickly access records using contact person. Therefore, in addition to the primary key, this can be indexed as secondary key. So when you need to search frequently, when you need to access frequently, when you need to when you need to do faster discoveries, so then you are assigning secondary key, not just secondary keys also. So there can be some other keys also, right? These alternative keys, you can use secondary keys. And when there's a secondary key, again, there's a problem. So that means there can be transitive dependencies because other attributes are dependent on this also, means there are possibilities to have transitive dependencies, but that is not asked here. So that can be future issue. But we don't need to concern that much on particular facts when practically when we are doing. So because this the names and all, normally we are using IDs normally for primary keys, and we don't concern much about separating name and ID two tables, or we are not thinking about separating that for preserving the transitive dependency, or not preserving, so removing the transitive dependency. We don't do such things unless it is affecting the deletion, searching, updating. We don't worry, we don't bother about that. Okay, so the next one, finish. Write an SQL query to display the shop ID and the location of all shops where grocery specialism. Okay, so this you have to tell. Write SQL query to display shop ID and the location of all shops where the grocery is the specialism. So the question itself carries the answer, right? Okay, tell me, question itself carries the answer. So this is like easy one. Question එකේම කියලා තියෙනවා මොකක්ද කරන්න ඕන කියලා. Only thing is you have to replace this English with SQL. Replace the English with SQL and you'll get the answer. Okay, I need you to tell the answer. Try it. Hello, again muted.
Select the location from shop ID.
Select
shop ID.
Right. You have to display shop ID and location, right? Then select shop ID location from
shop.
From shop. Okay.
Where
Where. Okay. So that is good replacement. Select shop ID location from shop where.
Retail
You are lagging. Since you are lagging, so just
retail specialism.
all right. Where retail
equals to
specialism
grocery.
equal grocery. Yes, correct. Where retail. So here, this is the retail specialism. So then you have to say we select shop ID location from shop where retail specific specialism equal grocery. That's why I said the question itself, these are very easy questions. The question itself, answer is given. Okay, the next one. Try for the next one also. Next one. Yes.
Insert.
Sorry.
Insert shop supplier.
Insert.
Into shop supplier.
Insert into. Okay. So the existing shop, Tiana shop, the existing shop with the ID 8765 has just used existing supplier. So both are there for the first time. And you have to add this data to the database. That means currently you have the supplier, currently you have the shop also, but they have started their first dealing. Right. So then what is the insertion query? Insert into which table?
Shop ID.
Shop ID? Shop ID is not a table. Insert into the table name.
Oh, insert into shop supplier.
Shop suppliers, because it is already there in the other two tables. So insert in shop supplier. Then you have to tell the fields that you're going to insert. So it's like this. Insert into the table name shop supplier. Then the field names you can say even without field names you can insert, right? But you have to give in order. Shop ID and supplier ID. Then the values you're going to insert. So integers you can give without the quotation, 8765, that you can give without the quotation. And then inside the quotation, you have to give the next one, that is supplier 89. And that is it. And semicolon to finish. Okay. Right, this is the answer. Okay, the next question. So this is about SQL and okay. Right, I think that part is over. So then they're asking about hardware section. Hardware section. The first column of the following table give features of different types of printer. First column of the following table gives features of different type of printer. Put a tick into the cells to show which features describe the laser and inkjet printer. So asking about the printers, different type of printers. The first printer is impact printer. So the first feature is impact, the second one is non-impact, the third one is line, and the fourth one is page. Impact. So let me explain. Impact means the printer head touches the paper. So impact printers are basically noisy. The printer head will go and touch the paper. But non-impact printers are not touching. It is jet type. That means so you spray in the ink or you stick in the ink without touching the paper. So those are a bit less noisy. But especially impact printer, dot matrix is impact printer. It is touching the paper, so you can, when you print, you can hear a sound like creak, 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 because it's touching the paper. So that impact you can hear. So these impact printers are a bit noisy. So that is how we identify that easily. And non-impact printers are not touching, the printer head is not touching the paper. Line printer, you print line by line, and page printer prints entire page at once, or entire section, a specific section at once. So what do you think about the laser and inkjet? Are they impact printers or non-impact? Yes? I think again you are muted.
I don't think so.
Is it impact or non-impact?
I don't think so that they're impact.
Yeah, it's non-impact. Both are non-impact. So out of this, which is a line printer? Which print line by line and which print the entire page at once?
Inkjet goes line by line.
Inkjet line by line page. This is a page print. Okay. So this is how you should mark this, right? Then the two components of the inkjet printer are stepper, motor, and print head. Describe how each component is used in printing a page. So two components of the inkjet printer are stepper motor and print head. Describe how each component works when printing a page. So asking about the inkjet printer. Asking about the inkjet printer. What is the role of ink? What is the role of print head? And what is the role of stepper motor? Stepper motor means that motor is like stepping. It's going step by step. It's rotating certain degrees. Yes, print head. What print head does? Right, the inkjet is basically spraying. Inkjet is spraying the paint. So how it spraying the paint? It has, though, this printer head has small like what do you call nozzles, right? Small nozzles, and so basically, so these nozzles are spraying the ink. So you can just mention the feature, right? So print head, role of print head. Okay, please write down over there. Inkjet printer, inkjet printer, inkjet printer. So do I need to write here? Okay, let's write inkjet printer. Is spraying ink using small holes, or you can say nozzles, in the printer head. Small nozzles in the printer head. Small holes in the printer head. Ink is loaded. Ink is loaded through tanks, or you can say cartridge. So I can't remember this exact spellings for cartridge. So don't know my spellings are correct. I don't think much about that. Let me search that. RI, right? Sorry. CIRT, cartridge, DGS. That is the correct one, right? And I think it's erased. Just cut the word this. Ink is loads through cartridge or in tanks. And stored into these nozzles. Stored into these nozzles. Head is moving. Head is moving right and left. Horizontally. Head is moving right and left horizontally. And nozzles are ejecting, or I can say spraying. Nozzles are spraying ink to the paper. After spraying, nozzles are again filled with ink. After spraying, nozzles are again filled with ink. Right, while this happens, so basically while this happens, so there's a technical way of telling this also. So, but so I don't know whether that is there in your syllabus, but you can always check the marking scheme. So the technical thing is basically, so this each resistor is controlled by, each nozzle is controlled by, so basically resistors and transistors. So then that part, so I think that is too technical, but anyway, you can still explain in that way, but this method is, I think, will be okay, acceptable. And stepper motor. Stepper motor is basically the task of the stepper motor is, it's like it is connected to the, so you can see the internal structure. Let me, so rather than explaining that, let's show the internal structure. Internal structure of inkjet printer. Right, so this is this is not clear, right? So let me erase. So have you finished? Write down the note. Hello. Again, you are muted, I think. Have you finished writing down this?
Yes, sir.
Okay, let me clear this. Right, okay, you can see here, this is the print head and this is the nozzle. So there are like tiny nozzles. This just showing one nozzle. And this is charging electrode plates. And so this is how it is ejected or straight. And this is the place where paper is there, and you can see it's strain, and this is how it is controlled. And this is ink tank or the main tank, and these are the pumps. And stepper head. So yeah, the stepper motor. Right. That part is the print head is basically connected to the spreader head, but it is not showing here. This is animation, right? This is better. Right. So this is what I said, that if you can tell this ultrasonic vibration and how this, so because of the vibration only, this process, this is filling and right. So you can see how it is spreaded to the paper. The extra ink is collected using this gutter, and still still you can see the inkjet part, right? Still you can see the inkjet part of the printer, but you cannot see the stepper motor's role here. But just get an idea how it happens, right? Just get an idea how it happens. And just need to see what stepper motor is doing. Here the ribbon cable is there. So now I think I can explain with this. Okay, so this is the paper and the ribbon cable and ink cartridge. And here this is the print head and stepper motor. Stepper motor is connected to the cartridge. So this sorry, step motor is connected to the head using this ribbon cable. Right? So basically, what is the task of stepper motor is moving this head horizontally. So basic task is moving the head horizontally, right? So this is like moving this way, like this, moving both sides. Okay, then right. So basically, when you turn on only, so stepper motor has like it's not it's regulated. Regulated means the speed is right controlled. Still, speed can be controlled, and the motion can also be controlled. So let's say you want to print here in this part, then stepper motor will not move this way and up to the end because you are printing only when you're printing here. So it can be controlled, right? It can be programmed. So this programmed code will be sent to the stepper motor, and according to that only stepper motor is acting. Otherwise, you could use a normal motor, no? So if you use a normal motor, you can't program. But stepper motor, you can program. You can just control it. So that is the idea of using stepper motor. Okay, just let's fill this quickly. The paper discussion. That's the paper. Here. Okay, the stepper motor, role of stepper motor. So you don't want to say much about, because here you can see 5 marks given, here only 2 marks. No need to write much about this thing. Right, it is connected to the printer head using a belt. Within bracket, motion of the motor will affect will impact motion of the head. That's why it's connected using a belt. It is moving the head horizontally. It's moving the head horizontally. That is what, and it can, so no need to write that, it can be a programmable motor. Yes, no need. So these 2 points are enough. When printer is not printing, basically stepper motor stops. When printer is not printing, stepper motor stops. You can write that point also. When printer is in idle mode, motor stops. Okay, that is about the okay. Next, part C. So have you finished? The student has all working laptop computer is a small capacity internal disk to almost all storage space taken by the operating system. The application programs means the hard disk is filled. She need to buy an external storage device to store her data files. So what are the suitable storages? Yes, that's the easy question. So need to store the files. External storage. Can you suggest? Hello. I think your microphone is muted again, so you can't.
Hello.
Hello. Yeah, I can hear you. External storages that she can use. You can mention any.
A pen drive.
Pen drive, external hard drive.
Hard drive.
So it can be SSD hard drive or HDD, a normal hard drive or SSD, external hard drive or pen drive. So that's easy. Describe one advantage of choosing the device. Advantages of choosing device 1. What is that? One. Describe one advantage of choosing one of the devices. You can just tell choosing one. So select one and explain. So if she select pen drive, so what is the advantage? It's relatively small, right? It's relatively small, and it is electronic storage, right? Electronic storage, relatively small, and you can move easily. Right? Move easily, and it's a durable one. Pen drives, it's durable, right? So external hard drives basically is, or even I have used, those are not much durable. It has large capacity. Of course, after external hard drive, if you get it, you will get like big capacity, But the other hand, the problem is it's not much durable. There is a higher tendency. Still, I'm using. I have a pen drive, and I have like bought the pen drive in 2004. Sorry, 2006. Still, I have that pen drive. It's working. But the same time, I bought some hard disks. But now most of these hard disks are gone. Right. So larger capacity is advantage of hard disk, and robustness and easily movable is the advantage of using a pen drive. So you can write one of these. Okay, then question number 3. So how many pages we have? It's a large paper. Right. Question number 3. A computer has a microphone and captures voice recording using the editing software. The user can select sampling resolution before making a recording. Define the sampling resolution and explain how sampling resolution will affect the accuracy of the digitized sound. So what is sampling? It's asking about the explanation. What is sampling resolution and how it affect the quality or the accuracy. Yes. What is sampling? Digital sound. So the analog sound sampling. What is that? Can you remember the term sampling? Yes. No.
Well,
yes.
It's like the number of bits that are there in a sample, or the quality resolution of the sampling resolution is basically the number of bits or the quality of the sample that has
the
been
quality. Number of bit. It's number of intervals, no? So you can say bit depth. You can tell bit depth, right? So basically it is a number of intervals or number of values, right? So number of values taken, number of distinct values taken within in a given frequency, you know. So this is so let me show a diagram. So you can say sampling and quantization. So both goes together, right? Sampling and quantization both will go together, and I'll show this explain this correctly, right? You can see in this diagram. You can see in this diagram basically. Okay. So this is the analog signal. This is analog signal. And so what about the sampling rate of each? Okay, let's compare this with some other diagrams. So then otherwise you can't like just get that. Okay, let's say different sampling rates. Different sampling rates. How different sampling rates affect the sound. Hi. So see this. Here you can see, so number of intervals, the time is same for both signals, right? Time is same for both signals, and quantization levels are also same. So this is called quantization level, this side. The y-axis is quantization level. That is a number of levels that you are dividing, number of values that you are taking is quantization. Sampling means number of samples that you are taking per given time. Number of distinct or number of intervals. Here you have 1, 2, 3 intervals. But here you have how many intervals? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Here you have 17. So best case, if you can draw a small comparison like this and draw the signal that is very good. So the same quantization level, keep the same quantization levels in the both, but sampling level is different. So here you have taken only one sample, so the value is this, the beginning bit, right? You are taking the beginning bit. Here also you take the beginning bit and this. Here you take the beginning bit and so this is the value. Here you take the beginning bit and this is the value. So if you try to recreate the analog signal, you'll get something like this. Let's take the middle value and create the analog signal. And if you take the middle value, I'm drawing this. If you take the middle value, I'm drawing a signal like this. So you can see the generated signal is not, it's similar, it's quite similar to the original signal, but not the same. Or if you take the beginning value, again, you can generate a signal like this. Still, the generated signal is quite similar, but not the same. But if you take the second one, so let's take the beginning value and you can see I'm redrawing the signal. Taking the beginning value. Right. You can say signal is much accurate. The signal is much accurate in the second one. So higher the sampling rate, so it will be closer to the original analog signal. But you can't like recreate the original, right? Because digitization will drop some values, but so you can't create the exact same, but you can create like something similar. 99% 99999 point similar one you can create. That depends on the sampling rate. Okay, so here this is another diagram. So let me clear this. This is another diagram you can see. So this is a more, this has like, so we can call the bit depth, the sample rate and the bit depth, right? Then so bit depth comes here, right? Number of bits. So you increase the bit depth and sampling both. Sampling rate is increased, bit depth is also increased. And with increased bit depth and sampling, you can almost create the same signal. Increased bit depth and transform, you can create the same signal. And now let's go and answer your question paper. So asking, so what is the sampling resolution? Sampling resolution is basically, so not asking the sampling rate, sampling resolution. Sampling resolution is similar to the bit depth, right? Sampling resolution means it's similar to the bit depth. Sampling resolution is similar to the bit depth. So this, so no, here. Right here, sampling resolution is similar to the quantization levels. Here, sampling. So I got wrong. Wrong idea. Sorry, it's my mistake. I just explained what is sampling rate. Sampling rate comes this side, the intervals. Sampling resolution is the number of levels, that is quantization levels. Okay, that is called bit depth. Correct. That is called bit depth. You said the values. Yes, that answer is correct. Your answer is correct because sampling resolution is this and sampling rate is the other side. Okay, sorry for my mistake. So asking about the sampling resolution, number of quantization levels. Okay, number of quantization levels or number of levels you divide a sample. right there. Number of quantization levels or distinct values available to represent an analog signal in digital way, also called bit depth, number of bits, also called bit depth. If you are using 2 bits, how many levels? If you are using 2 bits, how many levels? This we already discussed. Yes. Hello.
Hello.
Yes.
Yes, sir.
So I didn't get the answer. Is still here. CALL, right? Also called bit depth. Okay. Tell me this. Okay, if there are 2 bits, how many possibilities to represent the sample? If there are 2 bits, how many possibilities? Yes. Siddharth, can you hear me or not? Hello. Your microphone is muted.
Hello.
So if there are 2 bits, how many levels?
Hello.
Yeah, I think your microphone is okay now, but you can't hear me. Like just reconnect after disconnecting. Please reconnect after disconnecting. Yes.
4.
4. If there are 3 bits, 8. So that's not called bit depth, right? If there are 5 bits, 32. So have you seen in MP3s this MP3 වල තියෙනවා දැකලා තියෙනවා? Have you seen like, so you have 1 to 8, so 1 to 8 bit MP3. So you have 1 to 8 bits. So in this digitizing, you have different, so 1 to 8 kbps, so kilobit per second, not bits, right? Sorry, kbps. How many kilobits are captured per second? So so you can see 1 to 8, 96. So earlier days it was like 16, right? 16. So very 16 earlier days. So you have like very low quality, but the bit rate or the hertz. So what is bit rate or the frequency? How many bits per second you are capturing? How many bits per second? So that is the frequency, right? So that is basically sampling and quantization both. Sampling resolution is the quantization levels that you have, and the other hand, sampling means the number of intervals you break, right? According to that, per second, how many bits you capture, how many bits you capture per second is called the frequency of the particular MP3 signal, right?
Right.
Here you can see in the sound bridge, you have different types. More bits, more quality, right? So more bits, more quality. Right here, bit depth is number of possible values to represent sample. Right? Bit depth is basically 24, 32 bit. 32 bit means how many? 32 means 2 to the power 32. So that is a very big value, right? 32 means 2 to the power 32. Bit rate refers to the number of bits within a unit of playback in a time. Per time, per given time, or per second, how many bits within the unit. Understood the bit rate and bit depth both?
Yes.
Right? Bit depth is number of bits per time. Bit depth is a number of possible values to represent, or the number of bits used. And bit rate is in a given time how many bits you get. Right? So that is for these sounds. And for images also this resolution applies. Image resolution means number of pixels. Right? And pixels per bit also. So number of pixels and pixels per bit represent, it's similar to this bit depth. Pixels per bit. So let's say you are using RGB 8-bit bit depth, red, green, blue, RGB 8-bit. So RGB 8-bit means, so each red color will have 8 bits, green 8-bit, blue 8-bit, altogether it is 8 plus 8 plus 8, 24 bits. So the possible colors to represent is 2 to the power 24. Possible number of colors, 2 to the power 24 number of colors possible. And then the resolution, in the other hand, means number of pixels that you use in the particular, the number of pixels you use to represent the particular image. So sounds and images use same theory, right? Sounds and images use same theory. Okay, let's simplify this. For image, I'm going to simplify and show this. So it's similar to the sound. Okay, let's say you have, so very small image. Let's say your bit depth is 2 bits. Per pixel. And you have your images, width is 20 pixels and height is 10 pixels. Then what is the total number of pixels? Yes, total number of pixels equal to, hello, I'm asking from you.
We would first multiply the width, the height.
Yeah, 20 by 10. It's equal to 200, right? 20 in height and 10. So 20 columns, 10 rows. It's 200. Pixel size. Pixel size. What is the size of pixel? Yes, size of a pixel. You have, if you have 2 bits.
Yeah.
If you have 2 bits, then the pixel size is, yes, 1. So here the pixel can have this color, 0, 0 color, 0, 1 color, 1, 0 color, or 1, 1 color. So there are 4 possibilities, but pixel size is 2 bits. Right? What is the image size then? Image size? 200 into 2, which means 400 bits. Understood how it is calculated? This is somewhat similar to the sounds, but not exactly. Bit depth is number of levels that you're going to take, the quantization levels that you're going to take. And then the frequency is number of bits that you're going to represent per second. Using that, you can tell the soundtrack size. Soundtrack size. Similar to that, image has pixels. The bit depth is the number of bits used per pixel. And then the resolution is the number of pixels. If you multiply this together, you will get the image size. Right? Okay, let's do practical one. Just then, so I'm going to take online Photoshop version. That is Photofia. Okay, I'm going to take a new one file. New. Okay, so this is also showing that. Let's open image. Open image. That is the easiest way. Okay, this is image. If I go to the image size, you can see, but here it's not really clear. Right, okay. So let's go to the Photoshop new file dialog box. When you're going to take a new file, you'll see this dialog box in the Photoshop. Yeah, this one. And okay, this is more clear. Right, okay. Now you can see how many horizontal pixels. How many horizontal pixels in this image? Hello?
Hello?
How many horizontal pixels in this image?
1366.
How many vertical pixels?
768.
And what is the total number of pixels?
72.
You have to multiply both, right?
No, you multiply.
Yeah, multiply 1366 multiplied by 768, and you'll get the total number. This is the total number of pixels. Okay, what is the bit depth or the color mode? It is RGB 8-bit. That means one pixel will have how many bits? If it is RGB 8-bit, one pixel will have how many bits per pixel?
8.
8 or 24?
24.
24, because RGB, all three colors has bits. R, G, and B. 8-bit means 8 plus 8 plus 8, 24. Right. 24 means how many bytes?
8 bytes.
8 bytes or 3 bytes? 8-bit is 1 byte. Hello?
Yeah.
It's 3 bytes, right? Okay, forget about the bytes. Let's multiply by the bits. Bit has 24. So then this much of size, this is the size of the image. Because each bit has 24 bits. Each pixel has 24 bits. Therefore, the width is 1366 and the height is 768. This is total number of pixels. One pixel will have 24 bits. This is total number of bits. How many bytes? You have to divide by 8. Then you'll get this number of bytes. How many kilobytes?
We should
Yes.
divide by
Divide by 1024.
1024.
This is the number of kilobytes. How many megabytes?
Divided once again.
Divide once again. It is 3 megabytes. So can you see this?
Yeah.
Right. It says the image size is 3 megabytes. That is the estimation. And see how it is calculated. Right. Similar to that in sound editing software. So I don't have one now. Similar to that in this way. So if you know the number of seconds, so let's say you have like you know the frequency bits per second and you know the number of seconds, then you can find the sound track size. Okay, even before download, you can calculate the sound track size. So similar to that, you can find the video size. How to find the video size? In video, you have something called FPS. What is FPS?
Yeah, frames per second.
Frames per second. So if you know, okay, assume this is the image size in a video. Image size in a video. That means one frame is 3 megabytes. One frame is 3 megabytes. Then this is original rendering size, right? If your video size is this, and if you have like 3 minutes video, then if your FPS is 25 frames per second, both මේ වගේ නම් frame එක. You have 25 frames per second. You have to multiply by 25. This value you have to multiply by 25. Then per second it is 75 megabyte. Per minute it is this per minute 4,502 megabyte, and for 3 minutes it is 3-minute video size of this resolution is 13 GB. 3-minute video, 13 GB. But can we actually produce such video? So producing is possible, but can we play such video? Can we transmit that video? Is it possible?
Mm-hmm.
No, it's 13 GB for 3 minutes. Then what about the movie? If it is 30-minute movie, it is 130 GB. If it is, if it is 3-hour movie, you have to multiply by 6. The 1 hour movie, so 260 GB, 1 hour movie, 260 GB movie. Then 3-hour movie closer to 1 terabyte. So that is the production level, right? But what will happen? You have something called compressing, lossy compression, lossless compression. Images also you have that, right? Lossy compression, lossless compression. MP3 also you have that. Lossy compression, lossless compression, lossless compression. So using these compression formats, these compression formats are JPG is a compression format, right? MP4 is a compression format. MP3 is a compression format. MKV is a superb compression format. Why? You can keep Blu-ray quality or quality video in a small size, right? MKV, you can just compress a high quality movie into a small size. Okay, then that's why the compression formats are there. So we learned a big picture. Now we have a big picture about all these representations in. So not just number representation, picture representation, sound representation, video representation, and the compression. So why compression is needed? Because you can't represent in this size. These sizes are really high. So if you represent in original size, it's very, very. So, but with the compression, so there are some lossless compressions. Lossless you can recreate the image, recreate the video without losing any information. But lossy compressions are like you are losing some information. So some information are irrelevant. Why? You can't see it in the eye. Right? You can't see some colors. Basically, your eye is not sensitive to see that colors. So losing that color is okay. But some colors is not like that. Some colors, if you lose, what will happen? You will not see the image properly, right? So lossy compressions are losing the colors. Lossy compressions are losing sounds. So, but lossless compressions are not doing that. So lossless compressions, it will take more time to compress. Lossy compression, it will take less time. Okay, that is about the compression also. Right, now you know all these things. Okay, let's go back to the paper. So are you okay with this theory discussion? Because I'm doing this theory discussion in parallel with the paper, thinking about the future questions.
Right.
So if you just need the answer for this, I can just do this faster, right? So tell me what you prefer. I can follow whatever the path. If you just need the answer for this question, I can just answer and go. Okay, see here. So I didn't see this paper previously. Mamme paper ka baluwe naha. See here. So that's what I said. I'm thinking of the future questions. Right? I explain about the sampling rate. So this question, but I didn't see this paper. To be honest, Mama dakkena make I just explained thinking about the future possibilities, but you can see the future is today. So unlike dialogue, right? So this is a dialogue. I don't know. Future is not tomorrow even. So because of this connection speeds, right? Okay. Explanation for this one. So sampling resolution we have given explanation of this one. The higher the sampling rate, so higher the sampling resolution. Higher the sampling resolution, more accurate. So you can explain higher the sampling resolution, it will give more values, more accuracy, more quality, and less quantization error. More accuracy, right? More quality, less quantization error. More accuracy, right. More quality, less quantization error. And more size also, right? The file size will also be high.
Yeah.
Okay. Define image resolution. You're asking the image resolution, that is easy, we discussed. That is horizontal pixels into the vertical pixels, that is total number of pixels. Right? You can say total number of pixels per unit even. Pixels per inch, or number of pixels in the image, or height into width, or number of rows into number of columns in pixels, whatever. A picture is drawn in and saved in 16 color bitmap image. State how many bits are used to encode the data for one pixel. 16 color. If there are 16 colors, you know how many pixels? How many bits? Sorry. To produce 16 colors, how many bits you need? Hello?
4.
4, yes, 4 bits, because 2 to the power 4 is 16. Correct. And the second picture has width and height. It is saved in 256 color bitmap. Calculate the file size in kilobyte. Okay, that's what we did. So I'm using calculator, right? So are you allowed to use calculator for this paper, theory paper?
No.
Non-scientific one, I think okay, no? Not okay.
Oh, what's it?
Non-scientific calculator?
Yeah. But any calculator is not allowed, sir.
Any is not allowed. So then you have to manually calculate, right? So anyway, 8192. But you can divide these numbers, right? Because 8192, you can see this, you can 1024 will divide karana blue. No need to have a calculator because you can divide this by 1024. Right? Okay, let's forget about the calculator. So you know the height and width 8192 into 256. 256. And you know the number of colors. Number of colors that 256 colors means how many bits? 8 bits, no?
8.
8 bits means 1 byte. Very simple.
Yes.
8 bit will one color will have 1 byte. So this number of bytes. Kilobytes, you have to divide for 1024. Then you'll get the kilobytes. Again, if you divide, so asking kilobytes or megabytes? Kilobytes. You're asking kilobytes. Then you can cut this, and this is 4. 4 into 256 is 5 to n. So sorry, here 8. 8 into 256 is 2048. Okay. The answer is 2048 because here 8 into 256, 256 into 4 is 1024. Again, into 2 is 2048 kilobytes. Right. So show the step. You have to show the steps, right?
Yeah.
You have to show the steps. That means you have to tell horizontal pixels 1892, vertical pixels 256, size of 1 pixel 8-bit, similar to 1 byte. Actually, you have to show this into 1. Okay, then the fourth one. Fourth one. The actual bitmap size file will be larger than the calculated value. As a bitmap file has a file header. State 2 items that are stored in the file header. Actual file will be larger than the calculated size. So because of the file header. So what is there in the file header? That is basically meta information. In file headers, you have meta information. Meta information means data about data. Data about data. For an example, file size is there in the file header. File type is there in the file header. Location of the image, maybe the author of the image resolution, dimensions, color depth. What else? Yeah, author, color depth, image resolution, location, size, name of the file. Right, all these things are stored in the file. These are actually file properties. These are called file properties. Okay, then the fourth question, let's discuss that quickly. Explain why a personal computer needs operating system. So we discussed this previously. Operating system is a middleman between hardware and users. Operating system is a middleman between hardware application software. Therefore, without operating system, you can't operate the computer. Basically, your computer is your operating system. Your computer is your operating system. You tell operating system, and operating system will tell hardware what to do. Right? Basically, you talk with the operating system. So it hides the internal complexity of hardware because you talk to the operating system. Do I need to give a note on this, or is it clear?
That's clear.
Sorry?
That's clear, sir.
Clear, right, okay. Then describe two management tasks. Operating system is other hand, you can say resource manager. It can manage resources such as memory. It can manage resources such as hardware. It can manage resources, file management, memory management, network management, hardware management, user management. Right? All these things are managed by. Okay, then you can say, explain that memory management. So how it is done? So memory is basically having a memory hierarchy. So in the hard disk, so there's something called virtual memory or page file. There are computers, so this operating system use pages, divide large programs into pages, manageable pages. And these pages will be swept into the memory and swept out from the memory. And that's how the memory is carefully managed. Otherwise, to store everything, you need a large memory. But you have limited memory. That's why management is needed, right? If you have enough resources, for an example, if company has enough money, more than enough money, no manager is needed. Because even you waste money, even you keep money, let's say you have a money garden in a company, which always grow. You don't need a manager, right? Manager is needed when resources are limited. Because manager must manage the resource. That is the idea.
Yeah.
Memory is limited. Memory is limited. So it is expensive as well. But storage is basically, you can say, relatively unlimited. Related to memory, storage is bigger. But if you are going to store everything in the memory, let's say you have like 2 GB program, Photoshop is 2 GB. When you open 2 GB, in the memory, you can see 2 GB. That is a big mistake, right? Let's say your Word is 1 GB. When you open Word, In your memory, it will take 1 GB. That is a big mistake. Right, then next thing is, let's say you have a movie. Movie is 4 GB. When you open the movie, in your memory, 4 GB is taken. You can't do like that. So what OS do? OS will divide this into pages, manageable chunks, and store in the virtual memory, and take the necessary pages, that is called swap in, and swap out the unnecessary pages. You have to explain that. Okay. Or do I need to give a note?
Understood.
Okay. Then file management. Right. File management. File management is another task. So basically, you have files, folders, and indexed file view or hierarchy, file register, and file permissions, file naming, and file types, file registry types are given by the operating system. So the file operations like opening, editing. So these features are also assigned by the operating system, and who can edit the permissions are also assigned by the operating system. So likewise, if you can explain the file management, memory management, maybe input output devices or hardware management, user management, different user counts, different people are given different authorization levels, an authentication algorithm, that is user management done by the OS. So then that's enough. Okay. Right. I think with that, we have to stop for today. And the paper is, so please try to complete the paper. And there's a ISA part also. You said that ISA part is easy to you know. And you have your DNS, HTML part. And yeah, form handling. I'll explain this next day, right? It's a blank. Those are blank pages, no? But up, yeah, 13. That means we have to explain this HTML part. If ISA is easy, then I'll skip the ISA part. Then very small section. We can just finish within 1 hour or 2 hours. Another 2 hours. Okay, then let's see your next week, right? Okay, thank you. Have a nice day. Bye.
Thank you, sir.